Hello, geometry students. Today we're going to be finding the volume of pyramids. So we're going to start with a warm-up today. We're going to be solving for our variable h. Hopefully you remember pyramids from a little while ago. The 17, you might recall, is our slant height. We called that our L. But today we're going to be working with h. So what do you see in this pyramid right here? My hope is that you see that right triangle. H is right there. 17 is right there. Now this bottom, all the way across is 16, but our right triangle is not all the way across. It's halfway across, so that's 8. And how do we find that third side in the right triangle when we know the other two? I can hear everyone saying Pythagorean theorem. So very good. Or maybe you're a super genius and you totally remember your Pythagorean triples. We have a Pythagorean triple that's going to save me a little bit of time instead of writing all the work in front of you. It's okay if you're not a super genius. I'm not either. Our height is 15. If you remember the Pythagorean triple, no work has to be done besides, oh, I know what it is. If you don't know that, you just got to do Pythagorean theorem. I promise you should get 15. Your h is 15. All right. So let's get to the good stuff. The volume of a pyramid. Write this formula down. 1/3 capital B, capital H. Where does the 1/3 come from? To keep this video short, not going to go through it. It's, you can find videos online. I think some of my favorite demonstrations, while it's not a way to prove it, but if you have solids and you like physical solids and you fill them up with water, if you fill up a pyramid with the same base as a prism, you can take the amount of water that would fill 3 pyramids and it'll fill the prism. I think it's pretty cool, but worth time looking at. But I got to get going so that you don't have to watch this video forever and ever. So capital B, just like it was for surface area, is area of the base, which is pretty easy to tell in a pyramid for the most part. Capital H, that is the height of the pyramid. So this is not what we were using when we were doing surface area. We use slant height, L. But for volume, we're going to be using capital H, which should be perpendicular to the base. Another way I like to think about it in a pyramid, slant height is kind of like you standing at the top of a pyramid and sliding right down the middle of one of the sides. Whereas the height of the pyramid is you standing at the tip of the pyramid and taking an elevator down into the center of it. So that straight up and down from base to top, that is going to be your capital H. That is going to be your height of the pyramid. So let's start doing some examples. I'm going to do 2, and then I'm going to ask you to probably pause and try the other 2. It'd probably be in your best interest to give it a go yourself. So find the volume of each of these pyramids, 1 through 4. Here we go. Number 1, looking at this pyramid, first thing I'm wanting you to notice, the base is a triangle. So we call this a triangular pyramid. What do we need for volume? Well, it's 1/3 area of the base and the height. So we need a value for capital B. We need a value for capital H. I'm going to take the easy one first. It gives us the height. This 12 goes right down the center. It is perpendicular to the base. Our height is 12. Area of our base. Our base is a triangle. How do you find the area of a triangle? It's 1/2 base times height, and that's confusing because I keep saying bases and heights. Base of the triangle, height of the triangle, not the pyramid, which is why we use capitals in lower cases. I'm hoping you recall for right triangles that we can always use the legs to be our base and our height of a triangle. So the area of this right triangle base is going to be 1/2 times 6 times 8. 6 times 8 is 48, divided by 2 is 24. So putting it all together for our final answer, 1/3 times 24 times 12. 1/3 times 24, which is the same thing as dividing by 3. That's 8 times 12. I think it's 96 units cubed. We're measuring three-dimensional space. So we've got to cube our units. I'm going to double check on my calculator that I did that multiplication right. Okay, I am good. So our volume of this triangular pyramid is 96 units cubed. Moving on to number 2. What's different about this one? Well, first of all, the base is a square. A little bit easier to find the area of our base then. 10 times 10, which is 100. Our height. Oh, this one would be a nice surface area problem. That 13 right there, that's the slant height. That doesn't go straight down to the center. That slides down the side. Just like for surface areas, when we didn't have slant height and we needed it, we set up a right triangle, and it's going to be the same thing here. We need the height, which, let me draw that in a different color. We need the height right there, and we have the slant height. So we're going to set up this right triangle right here to solve for our height. I'm going to redraw it down here. The slant height is 13. The base goes across 10, but the right triangle only goes half. So that's going to be 5. That's how we're going to calculate our capital H. And then how do we find the third side of a right triangle? We know the other two. Yes, Pythagorean theorem. Or, because I know all of you have the biggest brains, you might recall the Pythagorean triple. 5, 12, 13. So you might know without doing any work that the height is 12. So let's calculate our volume. 1/3 times 100 times 12. That is going to be 400 units cubed. All right. Take a pause. Think about this stuff if you haven't. If you're just writing, let it sink in. Think about, do I understand where capital B comes from? Do I understand where capital H comes from? And I would ask you to try 3 and 4. I would tell you to pause and see if you can start number 3 or number 4 or both and see how they go. I'm going to jump into doing them right now, but this is your moment to say, let me see if I can do this already. But here I go. Number 3. We need the area of the base. We need the height of the pyramid. It looks like the height of the pyramid is 10. There is our perpendicular distance from base up to the top. Oh boy. And then we look at our base. It is a hexagon. Hexagon's not the easiest things. Ooh, sorry about that. That was weird. Area of hexagons, not the easiest things in the world to find. But let's go through that. Hopefully you might recall. So area of a regular polygon is 1/2 times apothem times perimeter. I'm going to start with the easy one first, perimeter. All the sides around the base are 6. Our perimeter is going to be 6 times 6, which is 36. So I'm going to fill that in. And then we have to find our apothem, midpoint of a side to the center. And I'm hoping you remember we use right triangles to do this. I'm going to run through it really, really fast, but if you don't remember how to do this, it is worth your time going back through our old notes and checking this out. We're going to take 360, divide by the number of sides 6, which gives us 60 degrees. So for this triangle that I have drawn right there, that angle up at the top is 60. But we need to draw that apothem in, which cuts it in half. So we have to divide that 60 by 2. So we get this right triangle with a 30-degree angle up here. Now, the bottom of this right triangle, it's not going to be 6 because we cut that side in half. So that's 3. And I'm hoping you remember your 30, 60, 90 ratios. Your short leg to your long leg, we multiply by the square root of 3, so our apothem is 3 square root of 3. Now, putting that all together, I'm not going to round anything, but I'm going to simplify it a little bit. Our capital B, this is starting to get a bit crowded, I apologize, is 54 square root of 3. Plugging everything into our formula, 1/3 times 54 square root of, what is going on? Square root of 3 times 10. That is going to give us our volume of 180 square root of 3 meters cubed. That is the exact answer. Maybe on Math Excel it asks you to round to the nearest whole number, which, let me type that in my calculator, is about 312. But for the exact answer, it's 180 square root of 3. And then we get to the word problem. Oh, that's right. If you read this word problem, it's not that bad. Sports area shaped like a pyramid has a base area of about 300,000. This word problem is going to tell us all the information we need. And a height of 321 feet. What's the approximate volume? Well, they gave us everything that we needed. 1/3 times 300,000 times 321, and I don't want to miss any zeros. Looks like I'm getting, double check me, I hope I didn't do it wrong, 32,100,000. What's our unit feet cubed? Not too bad. Didn't even have to draw a picture. Normally drawing pictures is really good. That one didn't have to. And then we get to the problem at the end. This one is a little bit of a doozy. If you'd like to try it yourself, I recommend it, but it's a little challenging. Do not get me wrong. I think this problem is a little challenging. All right, what are we doing? We are finding the value of the variable in this figure, which is x. I see x in 3 places. So it tells us that the volume is 18 square root of 3. And since this is a triangular pyramid, we know that the volume formula is 1/2, not volume, 1/2 area of the base times the height of the pyramid. These things need to be equal to each other. So 1/3 capital B capital H equals 18 root 3. Looks like our height is 6. So they gave us something. Very nice of them. Now, capital B, the area of the base. This is going to take a second to go over. We have this triangle. All 3 sides are x units long. Do you remember what the angles are in an equilateral triangle? 60 degrees. And to find the area of this triangle, we need the height of this triangle, which cuts that in half. And this is where it gets a little bit tricky. We have a 30, 60, 90 triangle, where this length right there is x. But we need the height. And you have to do those 30, 60, 90 ratios, but with variables. The hypotenuse is double the short leg, so this is going to be 1/2 x. And the long leg is root 3 times bigger, so that side is 1/2 x root 3. Not the prettiest thing in the world. So the area of that triangle is 1/2 times the base x times the height, which is 1/2 x root 3. Yikes. All right. Let's start cleaning this up. 1/3 times 1/2 times 1/2 times 6. That's 6 over 12. X times x, x squared, and then we got a root 3 over there. That's equal to 18 root 3. Let's get rid of this 6 over 12, which is 1/2. And how do you get rid of a 1/2? You multiply by 2. So I'm going to multiply that by 2, that by 2, and oh, I'm running out of space. I'm sorry. We get x squared root 3 equals 36 root 3. If we divide by the square roots of 3, oh, this is challenging. X squared equals 36. And since x is a side and a shape, when we take the square root, that side is equal to 6. That might be worth watching once or twice. It's a lot of heavy algebra. Do your best with it. Ask us questions if you have them. And that is volume of pyramids. Thank you for giving me 15 minutes of your time today. Try out your Math Excel. Join office hours, send us emails, and have a great rest of your day.